Okay, this is going to be our last conversation inside of the mole. We didn't get a chance to go over this before we left for Christmas break, so I want to make sure that we have a chance to talk about molecular formulas. Okay, so molecular formulas can either be experimentally determined, it's either the same as the empirical formula or it's a simple whole number multiple of its empirical formula. Okay, so let's look at some examples here. Okay. So CH does not exist in nature, so we would say that this is an empirical formula. And if I were to add this mass up, I would do carbon, which is 12, plus hydrogen, which is 1. So this mass would be 13 grams per mole. Okay. Ethine, okay, this is going to be a molecular formula. Why? Because I can divide 2 and 2 by itself to get C and H. So this is going to be a molecular formula, where if I add these up, it's going to be 24 plus 2, which is 26 grams per mole. Okay. Let me keep going. Styrene. Styrene is not an empirical formula. This is because you can divide 8 by itself to get 1, which would take us back down to CH. So this is going to be a molecular formula. Okay, and if I do 12 times 8 plus 8, that's going to give me a molecular formula, or a molar mass, of 104 grams per mole. Okay, now let's look at this for a second. What is the small whole number ratio that gets me from CH to C2H? Well, it's 2, right? Because both of these are 2. And look at that. This mass is double to 26, okay? Same thing here. This mass to this mass is times 8, right? Which makes sense because there's 8 of both of these. Okay, let's do one more example here. Methanol is an empirical formula. Doesn't exist in nature. And it has a molar mass of 30 grams per mole. And if I look at ethanoic acid is a double multiple of these, which I would then assume that this is going to be multiplied by 2, and its molar mass would be 60 grams per mole, making this a molecular formula. Okay, so you can see to get from empirical to molecular formula, we're just multiplying the masses by whatever the whole number ratio is to get from the empirical to the molecular. Okay, so the relationship that we can develop between the two of these is a mathematical relationship, and what I can say is the molecular formula mass is going to be equal to X times the empirical formula mass, where X is some whole number. So like 1, 2, 3, 4, 8, 9, okay? Any number would be X. So when I divide the molecular formula mass by the empirical formula mass, I should get whatever number I had to multiply the subscripts by to get there. Okay, so let's look at an example. This says that the molar mass, I have a molar mass of 60 grams per mole and an empirical formula of CH4O. Okay, so what I'm going to do is I'm going to say molecular formula mass is equal to some X times the empirical formula mass, okay? So the molecular formula mass is 60, and that's equal to X times the empirical formula mass, which is going to be 32. So carbon is 12 plus 4 times 1 plus 16 is equal to 32. So this is going to be 32. So then to get X by itself, I'm going to divide both sides by 32. So X is equal to 1.875, so we're going to say our whole number is 2. So the molecular formula, now I just have to multiply each subscript by 2. So it's going to be C2H8O2. And that's going to be the molecular formula. Okay, let's look at one more. What if I have a molar mass of 62 and I have an empirical formula of CH3O. So this is going to be 62 is equal to some X times, this is just the same up here except it's going to be 31. So I'm going to divide both sides by 31. X is equal to 2. Therefore, the empirical formula will be C2H6O2. Or I'm sorry, the molecular formula. Okay, however, these questions are never this easy. Why? Because you know how to figure out empirical formula. Okay? So most of the time, what I'm going to have you do is solve the empirical formula and then figure out the molecular formula's mass. Okay, so let's look at an example here with number 3. Okay, number 3 says the compound methylbutynate has 58.8% carbon, 9.8% hydrogen, and 31.4% oxygen. Its molar mass is 102. What is the empirical formula and the molecular formula? Okay, so the first thing we have to do here is solve for empirical formula. So we're going to say percent to gram. So I'm going to say 58.8 grams carbon, 9.8 grams hydrogen, 31.4 grams oxygen. Okay, and then the next thing I have to do is convert. So I have to say question mark moles carbon. So for every 1 mole of carbon, I have 12.01 grams of carbon. So this gives me a total mole of 58.8 divided by 12.01. I get 4.3 sig figs is going to be 90 moles of carbon. I'm going to do the same thing here. For every 1 mole of hydrogen, it weighs 1.01 grams of hydrogen. So question mark moles hydrogen. I'm sorry, I'm moving a little quickly here. So I'm going to say 9.8 divided by 1.01. So this is going to be equal to 9.7 moles of hydrogen. I'm sorry, I'm in the way. All right. And then the last thing, I have to say question mark moles of oxygen is equal to, so I'm going to say for every 1 mole of oxygen, 16 grams of oxygen. So 31.4 divided by 16 is equal to 1.96 moles oxygen. And then the last thing I have to do is divide by the smallest, right? So I'm going to do divide by 1.96, 1.96, 1.96. So carbon is going to be equal to 2.889, which is 2.9. H is going to be equal to, this is going to be 5, because it's 4.94, which is 4.95, so we're going to take that up. And then this is equal to 1, okay? So I'm going to get an empirical formula of C3H5O, okay, sorry, C3H5O, but it also wants the molecular formula. So I'm going to do molecular formula mass is equal to, some X times empirical formula mass. So the molecular formula mass was 102, and that's equal to some X times the empirical formula mass, which is going to be 12.01 times 3 plus 5.05 plus 16, 57.08. So I'm going to divide both sides by 57.08. And I get X is equal to 2, or somewhere like that. It's like 1.8, so we'll make it 2. So this is going to become C6H10O2. And that's going to be the molecular formula. So empirical formula, molecular formula. Okay, so we'll try these, we'll try some more of these in class, and make sure if you have questions, you bring them. Thank you.